Okay, so the next part that we have here is some exercises related to parabolas. And so, for example, if suppose that you have this parabola over here, y squared is equal to 12x. Suppose you have y squared is equal to 12x. So if you have y squared is equal to 12x, so you want to know basically, you want to know the coordinates of the focus, the axis, the equation of the directrix, and the length of the lattice rectum. So basically the only thing that you need here in order to calculate all of those things about this parabola is essentially your a, basically. And we said that basically we have this parabola with the equation y squared is equal to 4 times a times x. So I can, based on this, I can write this parabola as y squared is equal to 4 times 3 times x, and that means that my a over here is equal to 3. And if I have this parabola in this form, that means that I have the parabola is basically in this orientation, and my f is over here, which with a comma 0. My directrix is over here as x is equal to negative a, and well, you know that this axis is the axis of the parabola, and this is the directrix, and so on and so forth. So now the coordinates of the focus of this parabola are basically f with basically coordinates a comma 0, which is 3 comma 0, and then you have the axis of the parabola. The axis would be basically the x-axis, which is basically y is equal to 0, and then the equation of the directrix. Directrix is basically x is equal to negative 3. X is equal to negative 3, and the length of the lattice rectum. The length of lattice rectum is basically 4 times a, which is basically is equal to 4 times a, which is equal to 4 times 3, which is equal to 12 units. So that is basically this first case over here. Then we go to the answers. And 11 point. So over here my focus is 3.0, axis would be x-axis, or y is equal to 0. The directrix is basically x is equal to negative 3, and the length of lattice rectum is 12. So the next thing that we have here is basically another parabola with as x squared is equal to 6y. Now if x squared is equal to 6y, okay, so now if you have basically some parabola like x squared is equal to 6y, when you have the second power of x, that means that your axis of symmetry is along the y-axis. The axis of symmetry of the parabola is along the y-axis, because over here you saw that when I had the second power of y, the axis of symmetry was along the x-axis. This parabola was basically something like this. And the same, and basically with the using the same logic, when you have the second power of x, your axis of symmetry is going to be along the y-axis. Now it's going to be along the y-axis. For example, if you have x squared is equal to 4 times ay, it's going to be opening upwards. It's going to be some parabola like this. If you have x is equal to negative 4ay, it's going to be opening downwards like this. So what this means is that, of course, this parabola fits with this parabola over here, meaning that x squared is equal to 4 times ay, and it's opening upwards. So that means that I have, if I write this as, if I write this parabola as, for example, x squared is equal to 4 times, and your a, in order to calculate your a, you have to basically, you see that basically over here 6 is equal to 4a. 6 is equal to 4a. That means that a is equal to 6 fourths, which is equal to 3 halves. So that means that you have to write 3 halves times y. Now 4 times 3 halves is equal to 6, right? So that means that your a over here is equal to 3 halves. 3 halves is 1.5, and so 1.5 would be basically some point over here. So if this is 1, for example, and this is 2, this point over here, your x over here is 0, your y is 3 halves, is your focus, and the directrix of this parabola is of course going to be somewhere over here at basically y is equal to negative 3 halves. So 1 and 2, so at negative 3 halves, y is equal to negative 3 halves is going to be your directrix, and this is your x-axis, this is your x-axis, this is your y-axis, and so your parabola is going to, this is your focus, and your parabola is going to be something like this. And so basically then the different things that you want about you need about this parabola are basically the coordinates of the focus, which is 0, 3 halves. So f would be 0, 3 halves. And then you have the axis of parabola. The axis is the y-axis. The axis is the y-axis. And the equation of the directrix, the equation of the directrix is basically y is equal to negative 3 halves, and the length of the latus rectum, the length of that is basically 4 times a. 4 times a, which is equal to 4 times 3 halves, which is equal to 6 units. So number 2, 0, 3 halves, y-axis, y is equal to negative 3 halves, and 6 units would be the length of the latus rectum. Question number 3. Question number 3 is you have some parabola like y squared is equal to negative 8x. So again, you can see that your axis of symmetry over here is the x-axis, and since you have a negative sign, since the coefficient of x is negative, the parabola moves, basically opens towards the left, like this. And so if I write this as, so the equation, the general equation for this would be y squared is equal to negative 4ax. So I can write this as y squared is equal to negative 4 times 2 times x, and that means that my a is equal to 2. Now if my a is equal to 2, then basically 1 and 2, negative 2 over here, negative 2 comma 0 would be my focus, and 1 comma 1 2, basically x is equal to 2 is the directrix. The negative 2 comma 0, the x-axis, and y is equal to, and x is equal to 2 is the directrix. The length of the lattice rectum is equal to 2 times a, which is equal to 2 times 2 is equal to 4 units. 4 units. I'm sorry, 4 times 2, which is equal to 8 units. I apologize. Okay, so that is number 3. Now, for example, number 4 is you have some parabola like x squared is equal to negative 16y. Negative 16y. Now, since I have the axis of symmetry is the y-axis, and since it's negative, it's opening downwards, and so I can write x squared is equal to negative 4ay. Now negative 4, so I can write negative 4 times y, and that is x squared, so my a is equal to 4. So 1, 2, 3, and 4 over here. Negative 4, actually 0 comma negative 4 would be this point over here, which is my focus, and 1, 2, 3, and 4 is my directrix, which is y is equal to 4 is my directrix, and the length of the lattice rectum. The length of the lattice rectum is equal to 4 times 4 is equal to 16 units. And the axis, of course, is the y-axis, and that's basically all that we need here. So number 4 is 0 comma negative 4, and the y-axis and the directrix is y is equal to 4, and that is 16. So that's basically, for example, number 4. Number 5. Number 5 is y squared is equal to 10x. So the axis of symmetry is the x-axis. If you have a second power of y, the axis of symmetry is the x-axis, and since it's positive, it's opening towards the right. So it's like that, and so I can write y squared is equal to 4 times a times x. That means that I can write this as if 4a is equal to 10, that means that a is equal to 10 fourths, which is equal to 5 halves. So I can write this as y squared is equal to 4 times 5 halves, 4 times 5 halves times x, and that means that my a is equal to 5 halves, or 2.5. So 1, 2, 3, and over here I have 5 halves, comma 0 is the focus, this point over here, and basically 1, 2, and 3. So this line over here is the directrix, x is equal to negative 5/2, and the length of the lattice rectum is equal to 4 times 5/2, which is equal to 10 units. Is equal to 10 units. So number 5 is 5/2, comma 0. The x-axis, negative 5/2 and 10 units. Number 6, you have x squared is equal to negative 9x. X is equal to negative 9, y. So the axis of the symmetry is the y-axis, negative, so opening downwards. And so I can write x squared is equal to negative 4ay. So negative 4a is equal to negative 9. So that means that a is equal to 9 to 4. 9/4 is the same thing as 2 1/4. 2 1/4. 8 9/4. So 2 1/4 would be 1, 2, and 3, and 2 1/4 would be over here. So that is basically 0, 9/4, and then 1, 2, and 3 over here. Y is equal to, so this is a negative, of course, negative y, and y is equal to 9/4 is basically the equation of the directrix. The lattice rectum is basically 4 times 9/4, which is equal to 9 units. That is that. Number 6, 0, negative 9/4, y-axis, and y is equal to 9/4, and the length of the lattice rectum is 9 units. So the next question that we have is, now we have a couple of parabolas. Each of the exercise 7 to 12, find the equation of the parabola that satisfies the given condition. So we have a couple of points or some information, and based on that you want to write the equation of some parabolas. Okay, so for example, if your focus is at 6, 0, this is your F, and your directrix is at, is basically x is equal to negative 6. But even this is enough. Basically, basically considering what we are doing right now, only considering these 4 cases, meaning that either your parabola is going to be this way, or this way, or this way, or this way. So there is only 4 cases, but I mean normally parabolas can move anywhere in the plane. For example, you can have a parabola, for example, like this. You can have a parabola, for example, like even like this. Meaning that the axis of symmetry would be this axis over here, and the axis is a little bit tilted, for example. So anything is of course possible, but basically considering only the very simple 4 cases that we have, when I know that my focus is at 6, 0, then 6, 0 is basically some point over here, for example. So then automatically I know that my parabola is going to be this way, and of course the directrix is going to be the same distance away from the origin, and so the equation of this is going to be is going to be basically not x but y squared is equal to 4 times a positive 4 times ax. And so since a is equal to 6, I can write y squared is equal to 4 times 6, 24x. That is basically the equation of your parabola. This is number 7. Number 7, 24x. Or basically question number 8 is, for example, you have your focus at 0, negative 3, and your directrix as y is equal to positive 3. So even again this would be enough, since I know that basically my focus is at 0, negative 3 over here, 0, negative 3. What that means is that then my parabola opens this way downwards, and my directrix is going to be over here, y is equal to 3. And so the equation of this would be basically not y but x squared is equal to 4 times, actually negative 4 times, since opening downwards, negative 4 times a y. And so since a is equal to 3 here, I can write x squared is equal to negative 12y. That's the equation of this parabola, number 8. Or number 9. Number 9, you have the vertex at 0, 0. This is your vertex. And then you have the focus at f at 3, 0. So again, this is enough. You know that your focus is at 3, 0. So 1, 2, 3, 0 is your focus, f at 3, 0. It means that your parabola opens this way, and so this is going to be equal to basically not x but y squared is equal to 4ay. Since a is equal to 3 here, this distance, so then you can write y squared is equal to 4 times 2 is equal to 12y. I'm sorry, 12x. Y squared is equal to 12x. Number 9, y is equal to 12x. Or number 10, you have another parabola. The vertex is at 0, 0. The vertex, and the focus is at negative 2, 0. Is at negative 2, 0. So then let me check my food. Okay, so my focus is at negative 2, 0. So 1, 2 over here is my focus, negative 2, 0. And so I know that my parabola opens this way. So then I have not x but y squared is equal to negative 4 times ax. So my a is equal to 2 here. A is equal to 2, so y squared is equal to negative 4 times 2 times x, which is equal to, so that means that y squared is equal to negative 8x. Negative 8x. That is number 10. Number 10, y squared is equal to negative 8x. And the next one is number 11. The vertex is at 0, 0, 0, and passing through 2, 3, and axis along the x-axis. along the x-axis. So the vertex is at 0, 0. It's passing through this point. It's passing through this point 2, 3, and the axis is along the x-axis. So it has to, since it goes through this point, and one point is basically over here, so your parabola is like this. Now you need to calculate your A. You don't know what your A is, but the general equation for this would be y squared is equal to 4 times a x, right? So now, since you know that y squared is equal to 4ax, and the parabola goes through this point 2, 3, you can say 3 squared is equal to 4 times a times 2. So 9 is equal to 8a. So that means that a is equal to 9/8. So since a is equal to 9/8, you can write, using this equation, you can write y squared is equal to 4 times 9/8 times x, and that's a 2. So that means that y squared is equal to 9/2 x. Or you can write this as 2y squared is equal to 9x. You can do this as well. Number 11 is 2y squared is equal to 9x. The next question is the vertex is at 0, 0. Vertex at 0, 0, and passing through 5, 2, and symmetric with respect to y-axis. Symmetric with respect to y-axis. So sometimes we say symmetric with respect to y. This is the first time I ever read this way, but it's usually symmetric about the y-axis, for example. And what that actually means is that your parabola is, if it's passing through 5, 2, 1, 2, 3, 4, 5, 2 over here, if it's symmetric about the y-axis, it has to go through the origin as well. And so if it's symmetric about the y-axis, it cannot be this way. I mean, if I drew it this way, for example, then it would be symmetric about the x-axis. So it has to be this way. It has to be this way, and that means that your parabola is symmetric about the y-axis, meaning that there is symmetry here. As you can see, every point, the image of every point you can find through the y-axis. For example, this point, if you come over here and on the same distance, you will find another point of the parabola over here. So what that means is now your parabola is like this, and so basically you have x squared is equal to 4ay, and since you have x squared is equal to 4ay, and the parabola goes through this point 5, 2, then I can write 5 squared is equal to 4a times 2. 25 is equal to 8a, and a is equal to 25/8. So that means that then you can write x squared is equal to basically 4 times 25/8 times y, and you can simplify this here, and then you can write 2x squared is equal to 25y. That is the equation of your parabola. And this was question number 12. 2x squared is equal to 25y. Okay, so now we have learned enough about the parabola. The next thing that we are going to talk about is the ellipse. So we will learn some facts about the ellipses, how they are defined. We will derive the equation of an ellipse, and then we will also do some examples, some exercises like what we did over here in case of parabola. So I'll see you in the next video. Thank you.